Welcome back to Advent of Code, day 3. Got a minute to go. So the last problem we dealt with this range ID checking problem. Wasn't too bad. It could just be brute forced as well. You didn't have to actually be clever. Like, they could have made this harder. They could have made the number of digits like 10, 11, 12, 13, in which case you probably would have had to do something. Alright, 1 minute to go. So things might get difficult quickly because we've only got 12 days. So it's not like we've got 25 days of things to get difficult. Make sure I got my IDE, create a new file for 3. All right. You descend the short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Sorry about that, an elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if the escalator weren't also offline. Wait, so they don't have stairs? Isn't that like a massive fire safety hazard? Don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators. Okay. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. Wait, but an escalator is a staircase that moves, isn't it? You could just walk along it. Right? The batteries are labeled with their joltage rating. Joltage is something from 2020. All right. From 1 to 9. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The joltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. So it's in order as well. Okay. You need to find the largest possible joltage each bank could produce. In the above example, interesting. Alright, so we try to make the largest number. So how big are these banks? I mean, you could just brute force maybe, but you don't need to. You can just... I think generally you just take the biggest number for the first, and then the biggest number after that, right? But there'll be ties, so you need to look along all the biggest numbers. All right. Okay, fine. So, I think what we need to do is... we'll line in f.read lines. So, bank equals int x for... So, it's just a series of ints. Let's say m equals the largest value. So we range for I in range for I x in range in, so enumerate over the bank. If it's not the maximum, then skip it, because that can't be the biggest number. You need the biggest first digit you can get, right? There's no zeros as well. So we'll continue in that case. So then we go for j in range I for j y in enumerate bank from j plus 1. Is that how you use this? I always forget this one. Is that... We'll test it and see. Let's just say best so far equals 0. Ultimately, what do we want to do? Find the maximum. Just add up all the joltages, alright. If 10 times x plus y is greater than the best we've seen so far, then best equals update to be the new what we found now. And then after all this, we just keep some of them. So and 0, yay. Max bank. Well, let's check that the bank looks right. It's a generator object. Oh. It's supposed to be a... We should make it a list. J is not defined. That should be I. Whoops. One 7655. It's not right. Okay. I think I might have not done the enumerate correctly. I've just assumed. You can use it like that. Let's see. Let me just print IJ. I want to see what the values are here. from 7, 8. It's 9, 5. Oh, that's... Alright, you know what? This is long-winded. Why am I even doing this? Alright, what we do is... we take the first max, and we just find the max of the rest. Why are we iterating at all? So... don't bother with this. I don't know why it doesn't work, though. It's bugged, I guess. Alright, so, I equals... Yeah, but we don't want... So it's got to be... excluding the last digit, the last value in bank. Because that can't be a tens unit. Alright, so we take the max amongst them. And then we take the first such. So I equals bank dot is there a find method, but it's not a... It's not a... Oh, how do you do this? Let me look this up. Index. Yeah. So it's equals bank.index m. So we find the first item, and then we want let's say x equals 10 times m, and then, or just, I don't know, y equals max of bank from I plus 1 onwards. And then result plus equal 10 times m plus y. That has to be the biggest, right? Does that give us a different answer? What was the answer we had before? 17655. 17430. I don't know if I, okay. I think there might have been edge cases, like, where you, so that was... Yeah, nothing springs to mind. I can't think about what I did wrong before. My number was too high, wasn't it? So I probably included edge cases where, like, the tens unit was the last digit or something. I don't know. But no doubt there's some tricky edge cases. All right. Part 2. The escalator doesn't move. Well, walk then, you lazy elf. The elf explains that it probably needs more joltage to overcome the static friction of the system. Learn about static friction? Stiction? Oh, no. Physicists don't really use the word stiction, do they? I don't think so. I think, at least back when I studied physics, I think people called it static friction, not stiction. I don't know why I don't like that word. It just doesn't sound right in my head. Okay, whatever. And hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. Wonderful. Would it not still be... the same process, sort of? I don't know. Alright. I mean, I think the same idea works. But we do 12 digits instead of 2. So... let's just say that's part 1. We'll do part 2 separately. So part 2. So this time we want to make a 12-digit number. We know there's enough digits. So we're saying the first digit should be the max, except it can't be... Alright, so we've got to go for... let's say R in range 12. So first we take the R digit R. So what do we... So we're trying to build up a number here, aren't we? So it's like num equals 0. Alright, so we also need a so let's consider, so I mean we can just put that there. We don't actually need to, we do need that. Okay, so we need some sort of index. Let's say I equals 0. Alright. So, we start by doing what we did before. We find the max. So, the max... The problem is we're copying... Okay. We shouldn't be making all these slices. Would it still work? We're doing it 12 times for each. Each is as long as 200. So to find maxes efficiently, what you actually want is... I'll just run it and see. Otherwise, we need to know the max for every subarray. But, and to do that, there are efficient ways to do that, but it might be fine. So we want it ranging from I up to minus 12 plus R. Let's think this through. So if R is 0, we're at the start, so we need minus 12, because similarly, when we... Oh, wait. We were at 0. We need... +1, I think. Because that would leave in the So, in this case, we had 2 digits. And when we're on I equals 0, it's basically minus 2 plus plus 1 to get minus 1. I think that's the same pattern. It just means there will be at least 11 spots left over to make a number. So, I think that's right. And the num will be 10 to the power of 12 minus R minus 1. I think a lot of this is confusing because a lot of indices thinking. All right, so that will be added to the num, and then we want to update this iterator to be bank.index m from I onwards. So I is just pushed to the next index. And then, is that it? I don't feel confident with this one. So that shouldn't happen. To the power of... Okay, first of all, that is multiplied by m. Um... Alright. Let's just see what value we're on. So we manage as far as oh, we should be pushing this at least to that. I think I is staying the same. Ah, that's the problem, and it's just sticking with the same max over and over again. It should be excluding that number. 9 is not in the list. Wait a second. Wait, these don't match up now. Hang on. What do I actually mean by this? That's not what I mean. This is what I mean. We take the index of that integer and we go after it because we're taking the slice that comes after that number. Right, but as far as that's like halfway. So when R is 11, oh, that's right. That doesn't sound right. Ah, when this is 0. Haha. Ah, okay. Okay. Don't use negative indices. That's just a dirty trick, a dirty shortcut. We can just specify so it'll be length of bank. Yeah, it's the same thing. It's sort of done with modulo arithmetic, but if it's 0, then it doesn't mean the end, it means the start. Which is... okay, that's a number. Way, first time. Not really. I don't really like the way I wrote that. I think it would have been better written as a recursion method. But slightly less efficient in terms of runtime. Like, if you know that you have 12 to do, then you might as well do all 12. So this is really the way you would write it in a proper software. You want to avoid recursion generally because of the open-ended nature of it and the potential for infinite recursion and stuff, but because this just makes indices confusing. If you did it recursively, you would just want to just basically be this R would be the index to tell you whether you're at the tens or the hundreds or the thousands unit, and you would just recursively call it with R and I. So R and I are basically telling you this is which unit I'm on, and this is like what part of the array we're allowed to use. Like we've already used the first part, so you just use from this part onwards. This is slightly inefficient because you don't really want to be making new slices, because that uses linear time every single time it's called. But if you've got the array, well, if you've got the array, then you want a is there a data structure that lets you find the max of every subarray of an array? You can for some, that's easy. You can find the sum of every subarray because that uses prefixes. I think there is a technique for doing that. I don't remember what it is. But it worked fast enough. It's like 200 wide, 200 by 200, so... The emphasis was on dealing with the large number construction. That was a good problem, though. Like, the trap, of course, is to have written your part 1 the way I did to begin with, which was to do a for loop for the tens, then for loop for the units. But no way can you do that for 12. But we know that the largest number must be with the maximum digit. And it must be with, and if it's going to be with the maximum digit, then it might as well be the first instance of that maximum digit, because that you don't lose anything by doing that. You only get a bigger number. So then the second digit would have to be the next biggest, which could be the same, and of course the first instance of that. So like just by looking at this, we can see it must be 9, 9. And then maybe like 6 or something. But you just got to make sure you leave enough digits at the end. Like you can't pick your first... Here, you can't pick this 9. And if there's no 9 before... Like it looks like this is an example. They just... Yeah, look, there's no 9 before. So this is an edge case. They're trying to trap you here. And this is one that will pass case 1, part 1, but it won't pass part 2. Because that 9, you could have used it for part 1, so 9, 5 would have been the answer. But for part 2, you can't use that 9, so it's got to be, you've got to exclude the last 11 digits. So like probably 7 or 8, 8, yeah, it'd be 8. Yeah. That's a decent problem. Probably technically the hardest one so far. Because it's the first time that brute force, at least, not really brute force, but just like a smart for loop type method wouldn't actually work. Alright. Oh, I didn't check the stats when I did it, but we were in the top 2,000 or so, probably. Hello, Forest Opus. Did I finish it? Yeah, just now. Yep, that was a good problem. A little bit harder than the previous one, so we might see a dip. Well, people are managing to solve it quickly now. Like, that. This is around the time they're all finishing it. That number's updating. Oh, well. I think it updates every few minutes, so... Yeah, that's this problem done. Have a look at the old leaderboard. I have a time-intensive solution waiting for part 2. I need to find the way to actually solve it correctly, that is. Yeah. If you're doing a time-intensive solution, I don't imagine it will ever finish. Because we're dealing with 12 digits. So, if you're doing something like 12 for-loop ranges off the list, then we're talking like 200 to the power of 12, aren't we? That's way too much. Test input ran pretty quickly. The test input, how big was the test input? That? Yeah. Well, in that case, it'll be 10, 15, so like... 15. Oh, but you're very restricted in how big the numbers can be, aren't you? Because it's 12 digits. So yeah, that is going to run really quickly because there's hardly any options. It's just you're counting how many gaps you would have. So it's, yeah, that's going to be really quick. Yeah, this seems to have been designed such that not only is the actual input much bigger, but the nature is quite different, because with the test input, you're practically using the whole number every time, so you're really just choosing where the blanks are, which can be done in, like, I don't know, cubic time or something, which is not too bad. Alright. So that is the leaderboard so far. Some people are doing it at the time it releases. Some people are probably just waiting till later. Oh, Umaro is doing it now. Nice. I wasn't sure if he was actually going to participate this year. Umaro and I have been competing in a lot of video games. We had a Mass Effect Legendary race a few weeks ago, me versus Umaro. Guess who won? It was on Insanity difficulty. Just the first game, Mass Effect 1. The answer is I won. Maybe we'll race again next year, the whole trilogy. It looks like they're building a big factory here, the North Pole factory. That seems to be what this place is. Also, what a lazy L. Like, it's an escalator, so it's a staircase. You can walk the staircase. He's really insisted on getting this escalator powered up so that he doesn't have to walk. Is this gonna be like that? Is it just like a really huge escalator? Like, I think I've been on the largest escalator in the world, isn't it? In Hong Kong. Oh yeah, but that's not really an escalator. It's like a travelator. It's like there's this section where there's huge travelator that goes up this alleyway, and there's lots of shops lying on the side of the travelator, so you can literally just ride the travelator and buy stuff from the shops as you're riding the travelator. But it has gaps between sections where you just walk on normal ground. So does that really count? Probably not. It's just a sequence of travelators. I don't know what the largest... Alright, well, now we gotta look this up, don't we? Largest escalator in world. Hong Kong. But it's a system. So it's 800 meters long, but it's a system of escalators. I want the largest single escalator in the world. Single escalator in the world is found in St. Petersburg metro system. Maybe we'll visit it in the Metro series, which I have to come back to play as well. Yeah, the Russian metro system seems pretty cool. And that's why there's a whole game series revolving around it. Metro 2033, Metro Last Light, Metro Exodus. Maybe one day I'll see it if Russia ever becomes visitable again in our lifetimes. Alright. Well, let's take a look at twitch.tv. Let's see whose bad cop is always doing problems in Bash. Alka is also in leaderboard that I'm participating in. Quite a few. Oh, well, I don't. I only have like 2 viewers. I only generally raid if I've got like 3 or 4. Just wanted to have a look at who's doing it though. Alright. We're done. So, tomorrow tomorrow I gotta catch a boat. So I probably won't do it at the release time. Unless the boat has Wi-Fi. I am not coding on a boat. That, funny enough, the very first Advent of Code problem I ever did was on a boat. And it was on the boat trip that I'm about to go on tomorrow. The same one, but in reverse. It was between 2 islands, and tomorrow I'm going back from the smaller island to the bigger island. But I wasn't doing it, streaming it or anything. I was just doing it on my laptop in the boat. That was 2019. 2019, yeah, but just before the pandemic hit, and then I got trapped on this island for like 2 years. Not truly trapped. I could have left, but why would I leave? It was so much better on this island than anywhere else in the world. Oh man, 10 years it's been. Not 10 years since 2019. 10 years of Advent of Code. Yeah, they will be smaller now. Only 12 days because Eric can't handle the insane amount of work it takes to make these, and fair enough. I mean, my first reaction was a bit disappointed, like I was hoping for a full 24-5 days. But on the plus side, at least I think there will be more people that can actually keep up till the end of the 12 days. Like when there's 25 days and you get struggle in day 5 or something, and then you look ahead and see there's 20 more days, it can be disheartening, and I think a lot of people just give up altogether when they see that. But if you see that there's only like 6 more days, I think more people might actually be like confident enough to actually continue all the way through the 12 days. And it's 25 days of hours a day. That's pretty intense during Christmas when you're supposed to be preparing for Christmas or with families or whatever, if you celebrate it. This is 11, isn't it? There should be 12 problems. days, 12 problems. Years. Yeah. Oh. Years, yes. It's been a decade and 1. Yeah, this is the 11th. That's true. I first discovered it around 2019, I think. Yeah. That was the one I participated in live. On a boat. I don't remember which problem I did on the boat. Alright. Oh, check out Captain Coda as well. I don't know if Captain Coda is doing it this year. No, not. He hasn't been streaming much. I think he's probably quite busy. He is a coding educator after all. He has stuff to do, but we'll see if he decides to do it, because there's only 12 days. It might be more manageable, because in previous years I think he had to stop like halfway through or something. Alright, I gotta get this video uploaded to YouTube. Seems to be getting a lot of views. The last couple of videos I uploaded got about 200 views, so people want to see the coding. Alright, that's it then. Bye-bye, and see you next time tomorrow. Oof. I might not even have Wi-Fi in the hotel I reach tomorrow. I mean, I should, but you never know with hotels. I don't know if I'll even go live tomorrow, so see you sometime in the future. I'm not sure when. Bye-bye.